So this lesson is all about medians, quartiles, and box plots. The median of a set of data is the middle value when the values are placed in order. For example, these values 3, 7, 9, 4, 11, 6, 2. Well, we want to place these in order. So let's just do that. 4 next, and then 6, and then 7, 9, 11. And you can see just by counting in from the ends that the middle one is the 6. It's got 3 values below it and 3 values above it, so it must be in the middle. But there is a formula for this. So this is the n plus 1 over 2 value. So let's just highlight that. So for example, in this case, we've got 7 values. So it would be the 7 plus 1 divided by 2th value, and that works out to be 4, i.e. the 4th value in this case. So that's 1, 2, 3, 4. So the median is 6, because 6 is the 4th value. So the median isn't 4 itself, but it's the 4th value. Now, the median, being the middle value, is 50% along the data. We can further split the data into 4 parts at 25, 50 and 75% of the way along the data. So 50% along the data is just the median, but the quartiles are 3 values that split the data into 4 parts at 25% intervals. So looking again at our values from before, 2, 3, 6, 7, 9, 11. So the 6 is the median, and there are 3 values below it. So out of those 3 values, the middle value is a 3. And then there are 3 values above the median. So the middle value of those 3 is a 9. So those are the 3 values that split the data into 4 parts. We call the lower value the lower quartile, or also Q1 for short. We call the higher value the upper quartile, or Q3 for short, and then the middle quartile is just the median. We can call it quartile 2 if we like, but it's more commonly referred to as the median. So I've got 4 questions here. Find the quartiles for each of these 4 sets of values, and they've got respectively 8, 9, 10 and 11 values in the set, so each of those presents its own problems. So do pause the screen and have a go at these. Okay, so spoiler alert, we're just going to do question A. So I'm going to start by putting the values in order. So we'll go, there's a 1, there's a 2, there's a couple of 3s, couple of 4s, a 6 and a 7. So we have got 8 values. So the median is the 8 plus 1 divided by 2th value, which is the 4.5th value. So that would be halfway between the 4th value and the 5th value. It would be in there halfway between 3 and 4. So we say that the median is 3.5, halfway between the 3 and the 4. So having established the median point, we've got 4 points below and 4 points above. So thinking about 4 values, the halfway of 4 values would be 4 plus 1 divided by 2, which would be the 2.5th value. So we've got to go halfway between the 2nd value and the 3rd value. So the lower quartile is halfway between a 2 and a 3, which is 2.5. And similarly, the upper quartile is halfway between a 4 and a 6, which is 5. So the upper and lower quartiles are 2.5 and 5 respectively. Going on to the next one, well, we've got 9 values, halfway between 9 and 1. 9 plus 1 divided by 2, I mean to say, is 5 values. So the median is the 5th value. We have, of course, got to put these in order. So the median was the 5.5th value, so between the 5th value and the 6th value. So the median is 3.5, halfway between a 3 and a 4. And then that splits the data into 5 at the bottom and 5 at the top. So the middle of the bottom 5 is the 3rd one, which is a 2. So the lower quartile is 2. And then the middle of the top 5 values is a 5. So the upper quartile is a 5. Okay, and then going on to the last group of values. So again, I'll try to put these into order. And this time we've got 11 values. So 11 plus 1 divided by 2 is 6. So the median is the 6th value. So 1, 2, 3, 4, 5. The median is the 4. And then above that 4, we've got 5 values. So the middle of the 5 values is a 2. And then, above and below the 4, we've got 5 values. So the middle of the upper 5 values is the 7. So the lower quartile is 2. The median is 4. And the upper quartile is 7. And those are values that split the data into equal 25% chunks. So I'm now going to talk about box plots, also known as box and whisker diagrams or various variations on that. And these show the quartiles and range of sets of data. And you often use them to compare one set of data to another set. So for example here, I've got some let's say, a maths test, boys' scores and girls' scores. So at the risk of being sexist here, I've already put the scores into order. So the lowest boys' score is 1, and the highest boys' score is 45. The middle value is 14, so that's the median. There are 4 values below the median, so the lower quartile is between the second and third value. So the lower quartile is 7.5, and then there are 4 values above the median, so the upper quartile is between a 25 and a 27. So Q3, the upper quartile, is 26. And then similarly for the girls, the lowest is 12. The highest is 50. The median is, where is the median? Let's just count these. The median is 43. And then there's 4 below the median. So between a 14 and a 28, 14 plus 28 divided by 2 is 21. So the lower quartile is 21. And then the upper quartile is between a 47 and a 48, which is 47.5. Now, by the way, there are other conventions for working out the quartiles, where you go kind of a quarter of the way along and 3/4 of the way along. So a couple of different conventions for that, be aware, but I like doing it this way. So I've got a scale with the scores on, and I'm going to try and represent all of this data with something called a box plot, or a box and whisker diagram. So the lowest boy's score is a 1. So I'm going to put a line with at the 1. So the scores are here, by the way. And the highest boy's score is 45. So I'm going to put a line just at 45. The lower quartile is 7.5. So I'm going to put a line at 7.5, which is just about here. I should be doing this with a ruler, really. And then the upper quartile is 26. So I'm going to put a line at 26, which is here. And the median is at 14, which is here. So I'm just going to make a box at the quartiles and then make that into a line showing the whole range of the data. So I should be doing that a little bit neater. I can fix that in a minute. But you've got the whole range of the data shown, and you've got the quartiles. So that's the middle 50%, in other words. So the middle 50% of the data is shown by the box. The whole range of the data is shown by the whisker. And then you've got the median just shown by a line in the middle of the box. So those are the boys' scores. Similarly, I can show the girls' scores. So the lowest girls' score is 12. The highest girls' score is 50. The lower quartile for the girls is 21. The upper quartile for the girls is 47.5, which is about there. And that makes our box, the middle 50%. Our whisker makes the range of the data. And then finally, the median for the girls is 43. So that is just about there. So there's the median. So I tidied that up a bit, boys' scores and girls' scores. So as you can see, you get a comparison between the boys' scores and the girls' scores. And generally, there are two things that a box plot is good for, and that's showing you the central tendency of the data. So what does that mean? Well, it just means kind of where is the middle of the data? What are the scores like generally? And it also shows us how spread out the data is. So it looks like the boys' scores, well, the range might be higher, but the middle 50%, so most of the data is a little bit more spread out for the girls. So apart from a couple of extreme values, generally there's more spread amongst the girls' data than amongst the boys' data because the interquartile range is greater. So let's just write that down. So we can write that a box plot is good for comparing the central tendency and spread of sets of data. So in an exam situation, you might be asked to compare two groups, the boys and the girls. So you could write the girls' scores are generally better, and then you can support that with a statement that the median is higher for the girls. So the median is, you can see on the box plot, higher for the girls than the boys. And in fact, it's 43 compared to 14. So higher median. Let's just write 43 compared to 14. And then there's a greater spread amongst the girls' scores. So you can see that from the fact that the middle 50% there is much more spread out. Now the actual spread in terms of the range for the boys might be a little bit higher, but that's affected by a couple of outlying values. Generally, most of the girls' scores are more spread out, and you can tell that from the middle 50%. And you can talk about the interquartile range. So the upper quartile for the girls is 47.5, whereas the lower quartile for the girls is 21. So the interquartile range is 47 minus 21, which is 26.5. So the interquartile range is the spread of the middle 50%. And that's compared to the boys, where the interquartile range is 26 minus 7.5. So the middle 50% for the boys only has a spread of 18.5 scored.